Hi everyone, my name is Jasmine, and today we will be learning about how copycat snakes might be losing their ability to bluff. So what do I mean when I say a snake is a copycat? Scientists have a term called Bayesian mimicry. The main idea behind this is fake it till you make it. Bayesian mimicry is when there is a mimic, a harmless animal, that copies some behavior or characteristic of the model, a predatory animal, in order to fend off predators. In this case, let's look at how gopher snakes can vibrate their tail to sound just like a rattlesnake rattling the at the end of its tail. First, let's break down the difference between gopher snakes, the mimic, and rattlesnakes, the model. Gopher snakes and rattlesnakes are often confused with each other, but they actually have a few defining characteristics to help us keep them straight. Luckily, gopher snakes are harmless to you and me. They are non-venomous, so if they bite you, it might hurt, but it won't cause the terrible symptoms that snake venom typically causes. Gopher snakes have a narrow head and body, they're shiny, and their tails are thin. Since they don't have a rattle, they fake the sound by rapidly vibrating their tail. Rattlesnakes, however, have more predatorial features. Their heads are shaped like a triangle, and they have thick, dull bodies. Their tails are blunt with a rattle at the end that it shakes when provoked to make the iconic rattling sound. They're venomous, so their bites are quite dangerous to humans. So if you see one, it's probably a good idea to put some distance between you and the rattlesnake. But what if there aren't any rattlesnakes in the area? This made scientists wonder if gopher snakes can still imitate the rattle accurately if they're in an area without any rattlesnakes to mimic. To answer this, researchers, including one from UNC, conducted a study. To do this, they assumed that comparing the tail vibrations of gopher snakes that live with rattlesnakes with gopher snakes that don't live with rattlesnakes will show a more accurate imitation in the snakes that do live with rattlesnakes. So to do the experiment, they chose gopher snakes from 4 locations, 2 mainland California locations and 2 islands off the coast of California, Santa Cruz and Santa Rosa. These locations were pretty geographically similar. The only real difference was that rattlesnakes lived on the mainland and not on the islands. They then took some measurements to eliminate any differences, and they spooked each snake with a stuffed mammal head, its natural predator, on the end of some snake tongs. This caused the snakes to vibrate their tails as a defense mechanism, which they then measured and compared using a lot of different tests. For context, rattlesnakes typically rattle their tails for a pretty long time to scare off predators. So here's what they discovered. Mainland gopher snakes and island gopher snakes vibrated their tails similarly except for one factor. The mainland snakes did it longer than the island snakes by about 3 seconds. This makes sense because the island gopher snakes are not around real rattlesnakes, so of course their imitations are as accurate. If I had to imitate something that I had never seen before, I probably would have just started making things up. The fact that they still have relatively accurate imitations is impressive since they're doing it purely off instinct. So why is this important? This study solidifies the fact that animals can adapt and change themselves over time to better their chances of survival. This can happen through changes in behavior, like Bayesian mimicry, or physical traits that alter their looks. This is microevolution, and we can watch it happen in real time with this study. Their mimicry signal is evolving as more time passes between the 2 different environments. In the future, we could do so much more research to watch for bigger differences in mainland versus island snakes. This hints at the fact that island gopher snakes might be losing their ability to mimic rattlesnakes. And if this is the case, maybe it's happening in other species too.